Hey guys, I hope you're doing great today. This is our chapter number 5 in which we are going to learn about Google Compute Engine. Guys, this is one of the most used services because it is related to spinning up virtual machines, VM instances, bare metal servers, and so on. So I thought that we should have a deep dive in Google Compute Engine. That is why this whole lecture is dedicated to GCE, Google Compute Engine. And we have covered so far IAM service accounts and IAM roles. So this is our second service after IAM that is extensively used while we are working on any Google Cloud platform. After all, we have to configure and run our applications on virtual machines. So that is why this is one of the key and one of the most frequently used Google Cloud Platform service, GCE, Google Compute Engine. So let's get started and make sure that you subscribe DevOps Molvi for all these Google Cloud Platform lectures. We are covering a lot in Google Cloud in this series. So we are heading towards our chapter number 5. Let's get started. So what is our goal in today's lecture? So we are going to understand number 1, Google Compute Engine basics and grasp what Compute Engine is and its role within the Google Cloud Platform. And number 2, learn to create and configure VMs. That is actually our lab session in which we are going to learn and we are going to practically spin up a couple of virtual machines on Google Cloud Platform, and we are going to connect, and there are a lot of other stuff that we are going to discuss in our lab session as well. Gain hands-on experience in setting up VM instances, selecting machine types, and configuring storage and networks. Storage means attaching disks, and network means firewall rules, VPC, and we are going to implement automation and scaling as well. And we are going to explore instance templates, manage instance groups, and auto scaling to handle various variable workloads. And number 4, optimize cost. Learn how to manage and minimize costs using committed use discounts, preemptible VMs, and efficient resource allocation. So these are our 4 main goals in today's lecture. A quick throwback before we head towards Google Compute Engine. You know that this is one of my routines to have a quick review of what we have covered so far. And we have covered IAM, Identity and Access Management in Google Cloud Platform, and learned about the importance of IAM in any organization. And number 2, explored service accounts. I hope that you know about service accounts, principles, and roles. And we have also learned about IAM roles and their types, basic roles, predefined roles, and custom roles. Okay, so I hope that now you know about the owner role, viewer role, editor role, and also you know about the predefined role like compute admin, storage admin, and permissions inside those roles. And I hope that you have created your own custom roles with least privilege principle. So we had also few lab sessions where we created service accounts, granted access to principals, used basic and predefined roles, and lastly we created custom IAM roles using the least privileged permissions. So that was our quick throwback. Now, what is Compute Engine or GCE, Google Compute Engine? This is one of the biggest services of Google Cloud Platform. Okay, just like we have EC2 instances, we have Azure VMs instances on Azure and EC2 on AWS, Elastic Compute Cloud. So we have Google Compute Engine. Okay, and Google's terminologies are like Google App Engine, Google Kubernetes Engine. So this is our Google Compute Engine, GCE. It is Google Cloud's infrastructure as a service platform. So Google Compute Engine is a Google Cloud's infrastructure as a service platform that provides highly customizable virtual machines running on Google's infrastructure. Google's infrastructure itself is one of the most powerful compute infrastructure. So that's why Google is offering infrastructure as a service. In infrastructure as a service, you are getting virtual machines. You can run your virtual machines on Google Cloud Platform. There are hundreds of different types of virtual machines that you can run on Google Cloud Platform. So GCE is actually infrastructure as a service, and you can run customizable virtual machines, and it also enables users to create and manage virtualized computing resources in the cloud, allowing for scalable, flexible, and reliable computing power suited to various workloads. And it depends on your application. So you can upscale or you can upgrade your virtual machines, and similarly you can downgrade your virtual machines on Google Cloud Platform, because Google Cloud Platform provides scalable, flexible, and reliable computing power. So this is actually GCE. You can have virtual machines using this service. You can build your infrastructure of servers, of virtual machines, VMs, using GCE, and there are a number of machine types, instance templates. So there are a lot of things inside Google Compute Engine that we are going to practically see in our lab. So what are the features of Compute Engine? So I have highlighted the following features. Number one is, of course, virtual machines. We can get on demand and customizable. Customizable mean that we can upgrade and downgrade virtual memory, CPU cores, disks. So these all virtual machines are really highly customizable, because we can upgrade, downgrade, we can terminate, we can reboot, everything we can do with those VMs, and they are tailored for our specific performance needs. And number two, high scalability. Scalability means to scale up the number of virtual machines according to the workloads. For instance, when our application is running in peak time and it needs resources, then our virtual machines should automatically scale up. So that is highly scalable virtual machines that Google Cloud Platform GCP engine is offering, and we can scale up from a single virtual machine to thousands, allowing for both small and large workloads. And custom machine types, it means that we as users can choose the exact amount of virtual machine vCPUs and memory which we need, optimizing cost and performance. And number four, global infrastructure operates across Google Cloud's global network of regions and zones for high availability and low latency. There are multiple regions that Google Cloud Platform offers, and you can run your virtual machine in the zone or the region of your choice. So we have storage options in which GCP provides persistent disks, local SSDs, and custom storage configurations to fit different needs. And we have networking capabilities in which GCP includes VPCs, virtual private clouds, load balancing, and firewall rules for secure and flexible networking. And by the way, this should be a separate topic. We are going to have a deep dive in networking on GCP as well. So integration with Google Cloud Services, using virtual machines on GCP, we can easily connect with other Google Cloud offerings like cloud storage, BigQuery, known as BQ, and Kubernetes engine, so making it suitable for complex multi-service applications. So these were the major showstopper features of Compute Engine. So We have virtual machines, high scalability, custom machine types, global infrastructure, storage options, networking capabilities, and integration of virtual machines with Google Cloud services. All right, guys. So now there should be a question in your mind that where do we use a compute engine? What are the use cases of this Google's infrastructure as a service? And we can use our virtual machines in web hosting, application development. Of course, we can run our websites on virtual machines. And just like in the old days, we have been running our websites on dedicated servers. So we can have dedicated virtual machines on GCP. We can have bare metal service servers on GCP to run our websites for web hosting and application development. We can have dev QA environments on GCP. Also, we can use compute engine for data processing and big data workloads, machine learning and AI, backend for mobile and web applications, high performance computing. There are virtual machines that are super powerful, have tons of memory and CPUs and storage. So we can use GCP for high performance computing. These are just concepts of we are going to see those virtual machines in our virtual machine types. And we can also deploy containers. Okay, we can directly deploy Docker and Docker containers on virtual machines. So we can have containerized workloads, batch processing, and containerized workloads again. So these are the use cases where we can use virtual machines. And by the way, guys, most of the compute engine virtual machines are used for running our applications like Node, React, Java, Apache Nginx web applications. So these are the most common use cases of compute engine. And now, core components of compute engine. So I have listed down these four major components of compute engine. So at least as a DevOps engineer or Google Cloud engineer, we must know these four core components, in which number one is machine types. We can choose the machine type based on our workload. If we have a zero or we need a dev machine, so we should not dedicate extra resources or large resources to that machine. After all, we are using it for dev purposes or QA purposes. So those machines should be having minimum resources. So luckily, Google Cloud Platform offers such kind of machines with minimum resources for our testing, for our dev or QA environments. And there are machine types with high amount of resources. But as we increase the resources, of course, the cost of these machines would increase. And we get the estimate of cost. Google Cloud Platform shows us the change in the cost when we upscale and downscale the resources. We are going to see it in our lab session. And we can have images, okay, OS images, predefined images or custom images. I can have my templates, custom images, just like we have snapshots to spin up new virtual machines, and disks, persistent disks, local SSDs, and storage options. Among SSDs are expensive, and we have multiple regions and zones in which we can have our virtual machine in any physical or geographical location like Europe, like US Central, India, Mumbai. So we have a choice to spin up our virtual machine in any zone or region of our choice. So these were the core components of compute engine. Now let's start our lab, in which we are going to run our first virtual machine and see compute engine in real. So let's get started. Alright guys, now I have logged in my Google Cloud Platform, Google Cloud Console. We have to click on these This is actually our navigation menu. I have clicked it, and now you can see multiple services that are offered by Google Cloud Platform, and these are all products of GCP. We already have discussed, we had an overview of all these products. Now you can see this is VPC network for networking, Cloud Run for deployment, CI/CD, and we have Compute Engine. And in Compute Engine, you can see we have a lot of other options. So we are going to discuss the major things, the major that are to the point, and we actually use them in our IT organizations. So first of all, starting with VM instances. Okay, so you should not feel overwhelmed. We are going to discuss the most relevant stuff. Now you can see we have this create instance button, and if I click on it, create instance, so after clicking the create instance button, you can see this screen. So for now I will not change anything. This is just a test, and I will hit the create button, and it will create a virtual machine with everything which is provided by default by Google Cloud Platform. So let's see if I have clicked on create instance, where our virtual machine will be spinned up. Alright guys, our virtual machine is now running. So you can see the default zone that it's selected. Now it was actually by GCP, and I didn't change the zone. You see I didn't change the name as well. So we got an internal IP and an external IP. So from here I can connect to the SSH, I mean terminal, using this option. So by default we have these keys that are stored in our account, so we can use those keys to log in to our virtual machine. Now you can see I have logged in and cat etc issue. So we have Debian 12 operating system running on this our virtual machine. But now we are going to create a new virtual machine in which we are going to see the options and major stuff that we should know as a Google Cloud engineer. I will click on create instance. Okay, and we are going to create a new virtual machine. Now here I will give the name of my virtual machine, DevOps Molvi VM. And now from here we can have the region. So I have selected this US East 4, and I will click on, for instance, this zone. Okay, so now region is permanent and zone is permanent, where our virtual machine will be running. Now we can see multiple types of virtual machines. We have multiple virtual machine types, and machine types for common workloads, optimized for cost and flexibility. And by default it has selected E2. Okay, and you can see we can get from 0.25 to 30 vCPUs, and we can get from 1 GB to 128 GB of memory. And our platform, like architecture, AMD or 64-bit processors, AMD, Intel, and in E2 Google Cloud Platform will decide, and based on availability we get the architecture or the type of platform. So for instance, if I click on E2, and now we have further more options to customize our virtual machine. You can see the custom button, and from here I can customize the virtual machine. If I increase the resources, you will see the change in monthly estimate. For instance, if it is now $39.37 US, so now I will increase the cores to 6, and it will refresh, and our monthly estimate has been changed. For instance, if I increase the RAM, so that's why GCP is flexible. So we can upscale and downscale our resources. I have increased from 32. Okay, now it should be, and I don't have the enough quota for this. So there are limitations on this account. So you can see now I have 16 vCPUs, and if I increase to 60 GB, then the monthly estimate for this virtual machine would be $432, which is of course really expensive. So I will just change it to minimum. From here I can change. Also we have another option here, and in preset you can see we can also select the virtual machine type from here as well. There are E2 micro, E2 small, E2 medium. So we have I will show you again in preset. Here we can also use the custom machine types that GCP is offering, and now it would be very affordable, highly affordable, and you can see now it is just for $8 per month. But we are getting only 2 vCPUs, 1 core and 1 GB RAM. So this is ideal for dev or QA or for our own learning. Okay, and I can also change from E2 micro to E2 small or E2 medium. And for the sake of this lab, I will just click on E2 medium, in which we are getting 1 core and 4 GB RAM. Also guys, you can see other types of machines we can use on GCP, like compute optimized machine types for performance intensive workloads with highest performance per core. But you can see these are really expensive virtual machines, because these are meant for high performance workloads, and every machine you can see are $100 plus. From here we can have other machine types. For instance, if I click on C2 standard 60, and you will see the price. Okay, it is not showing, but there is monthly estimate of 2 grand, I mean $2,000, which is super, I mean expensive for beginners or students like us. So just for concepts, you can see we can have compute optimized. Similarly, we can have memory optimized, and you can see the ranges of memory RAM we can get using the memory optimized machine types. And memory optimized machine types are meant for workloads with high memory to vCPU ratios, like in in-memory databases. So for instance, if our application needs a lot of memory, then we have the choice to use the memory optimized virtual machines. But you can see the memory is 16,000 to 32,000 GB of RAM. So these would be super costly virtual machines. And similarly, if our application needs storage, and for instance storage intensive workloads like horizontal scale out databases, we can use the storage optimized. And lastly, we have GPUs, in which we can get the number of GPUs. So we can also try these, and you can see the monthly estimate of each virtual machine is updated as we change the virtual machine. So I'm heading back to general purpose, and in general purpose we can have other machine types with their platform. So this also depends on the platform. The platforms are different here. These are actually virtual machine architectures, like you can see Google Axiom, Intel Sapphire Rapids, AMD EPYC. So these are actually the architectures or platforms. So we can also use other machine types here. The monthly estimate would be updated accordingly. So by default, whenever you are logged in to your Google Cloud platform, you will see by default it is on E2, because these are the lowest virtual machine if we are concerned about the costs, and the CPU resources start from as low as 0.25 vCPUs and 1 GB RAM. So if you are looking for a virtual machine with 1 GB RAM, then we have the E2 machines, and in E2 medium I will get around 28 US dollars. That would be my monthly cost if I run this machine for one whole month. Availability policies, and so I will choose the standard. And if we are looking for more discounts, we can use the spot instances. So you can see in availability policies we have two types of policies. Okay, the number one is standard, and now you can see in standard we can have this virtual machine for 28 US dollars per month. But now if I want to use the spot instance, and if I get the same virtual machine, the cost would be ridiculously reduced to only 11.43. So you can see we can have spot instances, but for now I will just choose it as standard because this is for just for our lab. So you must have a concept about and the difference, about the difference between standard and spot. Terminate virtual machine, I will just migrate virtual machine, which is recommended. So these are actually the availability policies we have set to standard. And if in case of any infrastructure maintenance, Google Cloud Platform will migrate our VMs to other hardware without any downtime. So I have selected migrate VM instance recommended option. And after that, confidential VM service. Okay, this service adds protection to your data. So if we want to protect our data, then we can enable this service. By the way, it is disabled on this VM, so I will leave it as default. After that, deploy a container image to this VM instance. And if I click on deploy container, now you can see we can install Docker. We will have Docker pre-installed on this VM, and we will have, for instance, if this is the container image, then this would be running when our VMs will start. Okay, so we can also deploy Docker containers while we are creating our instance. So for now I will not use this option because we are just spinning up a VM. Now boot disk, this is the important part. And for instance, it is showing me Debian and I want to change it to Ubuntu. So now you can see there are a lot of other options. We can use custom images, we can use snapshots, archive snapshots, and we can also attach existing disks to this virtual machine. So for now I will use public image, and there are, you can see for instance, if I select Debian, and now we can have multiple options of operating systems that are available publicly: CentOS, container optimized OS, Debian. And if I want to select Ubuntu, I will click on Ubuntu, and you can see the releases Ubuntu 20.24.04 LTS. I will select the version and balanced persistent disk. If I select SSD, then of course it will be expensive. Our price will increase a little bit, and we can select the disk size, and it should be between 10, which should be the minimum size of our disk, to 65,536 GB, which is the maximum size for this VM. So we will leave it default, and 10 GB would be enough for our this lab. So I will select. Now you can see our image has been changed and the price has also been updated because we are now using SSD. Okay, new SSD persistent disk. So by the way guys, if you feel any confusion about anything, you can see we have this question mark against each term. And now for instance, this is boot disk, and each instance requires a disk to boot from. So we can have our query clarified if we click on this question mark. So after that, you can see we have an important part, while creating our VM instance is identity and API access. So I'm using the default compute engine default service account, and this role of course has the access to create virtual machines. You can see requires the service account user role to be set for user who want to access VMs with this service account. So this service account will definitely have the access to create and destroy or modify virtual machines on compute engine. And after that, this is selected by default, and access scopes allow default access. And if I want to allow full access to all cloud APIs or set access for each API, so I will keep it default. And firewall, okay, this is important, and I will allow both HTTP and HTTPS traffic to this virtual machine. And if I want to monitor our system through collection of logs and key matrix, I will have to install ops agent for monitoring and logging. So since it is a dev and a testing VM, so I will not install it. And after that, we have some advanced options like networking, in which we can have the host name, like this is DevOps Molvi VM. This would be our host name. And IP forwarding, I will not use this option. And now you can see this would be the network interface. We have a default network created for this zone and region, okay, and I'm using the default values of network and VPC. We will have a separate lecture in which we can also create a VPC and a network interface of our choice with default or with the IP ranges of our choice. So this is actually default. We can also check here in network and VPC. You can see we have VPC networks. There should be a default virtual private cloud, and we have firewall rules. We are going to have a full lecture on it, but for now you can see we have this default with 30 subnets, and we are using this subnet, this network for our virtual machine. Now you can see we have all these subnets created for all the regions, okay. You can see we have the region and we have the subnet. So for now I'm using this default network interface, and I will not touch anything, so I will keep them default. But we should know about every option we have here, like disks and backups. If I want to add a new disk, I can click on add new disk, and multiple disks can be attached to a single virtual machine. So that's how we can add multiple disks to this virtual machine. But since I don't need any additional disks for this VM, so I will keep it default. And just like for security, we have for shielded VM and SSH keys. So these are options that have been selected by default, so I will leave them as default. And after that, in management, this is one of the most important thing that we must know is deletion protection. For instance, by the way, it says when deletion protection is enabled, instance cannot be deleted. And if this is a production VM and we don't want this VM to be accidentally deleted at any cost, so we can enable deletion protection. I would recommend to have this check enabled so that no one can delete our virtual machine. So we are protecting our virtual machine from accidental deletion. So if I want to add some bootstrap script or startup scripts in bash scripts, so we can add those scripts here. So this is the management part. After that, we can have data encryption, which is the default value. So guys, there are a lot of values that are selected by default, so we don't have to worry about these values as a beginner or for our DevOps VMs. I will keep them as default, and now I will create the instance and our instance will be created in a while, so we have to wait for our instance. So similarly guys, we can also create a new virtual machine for our Windows platform. So if I click on create a new instance, I will open it in a new tab, and till then our this virtual machine should be up. So in order to create a Windows virtual machine, so I will select it as Windows VM, and I will have the zone change to B. After that, this would be E2, and I will, since it's a Windows VM, so I will increase the resources to 16 GB, and in boot disk I will change the operating system. From here I will select Windows Server, and now the version, since I want to use 22 data center, so I will keep this as default, and this is the minimum disk size that is required for booting up a Windows VM. So I will select it. The default, rest of the values would be default, so I will just hit, and also I will allow HTTP and HTTPS traffic. So I will just create a new Windows virtual machine as well. So it is going to take some time. So now you can see we have our Ubuntu virtual machine running, and I can click on SSH. So we can see that our Ubuntu virtual machine is up and running. I will click on authorize, and the keys will be transferred from this Google account to the virtual machine. And now you can see we have our virtual machine up and running. I can see the host name, which is DevOps Molvi VM, and if I want to check the release or version, I can see it is Ubuntu 24.04. So that's how guys, you can see we can spin up Linux virtual machines as much as we want. And now heading back towards the Windows VM, now you can see our Windows machine is up and running. I will click on RDP, and it will download the RDP file. So in order to use the password, since we need password, so I will click on set Windows password here, and click on set Windows password. It will take a few moments, and our password would be selected. Now for instance, if I click on this, and we have our password, you can see I will just copy the password and I will enter and OK, and our Windows machine is up and running. And that's how I can connect with my Windows virtual machine. Now it is a Windows VM. Okay guys, the Windows virtual machine is also up and running. So I will just minimize, and you can see we have our Linux virtual machine also up and running. By the way, you must be thinking that where are the SSH keys that are stored in the account. So we can also see those keys. Just give me a moment, and we are logged in. So in Compute Engine, you can see we have this option of metadata. Okay, so click on metadata, and you can see we have this SSH keys option. So these keys are actually used to connect with the Linux virtual machines. So we can use our own SSH keys. We have the private key on our virtual machine on our personal computer, and we can just copy the public key here, and from that we can use our own keys instead of using the Google Cloud SSH keys. So you can change your SSH keys from metadata just under settings in Compute Engine. So guys, now you can see we have two virtual machines up and running. So we just used most of the default values to spin up these virtual machines. In the next part, which would be part B, we are going to discuss about instance templates, sole tenant nodes. But as a beginner, we must know how we can create virtual machines how we can connect with virtual machines, whether it is Linux or Windows on Google Compute Engine. So that's it for today's lab, which is our part A. So part A is completed. I will see you in part B, where we will complete the rest of the compute engine. Make sure to subscribe DevOps Molvi. I will watch you in the next part of Google Compute Engine. Have a good one. Bye.